Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. This is the 8th installment in the Adventures with Python series, in which we learn Python by building a text adventure game. No prior programming experience is needed, but you should watch the series videos in order. I'll link the playlist here and in the description. Let's get started. So far, we've built a functionally decomposed game with a data structure representing our dungeon and a game engine composed primarily of a loop, allowing the user to explore the dungeon until they choose to quit. In the last video, we learned about the dictionary data structure in Python, which is critical to understanding how we're going to store and load our dungeon as a JSON, the topic of today's video. If you aren't familiar with Python dictionaries, please watch the prior video in this series. I'll link it here. In the last video, I suggested you convert each location in your dungeon from a list to a dictionary. I'm going to do that first in our program, which I've renamed to shabbyabbyv8.py. It's in my GitHub repository with the other files from this series. There's a link in the description. Each location in my dungeon is a list, and I have named constants that I use to index into the list. I'm going to make the dictionary keys the constant names, but lowercase. So this is a simple matter of enclosing each location in curly braces rather than square brackets and adding key : before each value. The keys are strings. I'm going to change my annotation for the Abby data structure to list dict str object. That's saying this is a list of dictionaries where all the keys are strings, but the values are different data types. Object is an accurate way of saying any data type, because all data types are objects in Python. Then anywhere I indexed into the location list, I'll just change the index from the constant to the key. That will be easy because the keys are just lowercase versions of the constant names enclosed in quotes. There's nothing to change in getExitString. I have several lines I need to change in getDescription, so you can see how easy that is. Nothing to change in inventory_swap. And in main, besides changing the dungeon itself, I have a few places where I'm indexing into exits or inventory. And I can now delete those indexing constants. Let's run it and make sure we didn't miss anything. Not a thorough test, but I believe I've got it. Now, that wasn't necessary for what we're going to do, but I think it'll make it clearer. If you decided to extend the dungeon in your game, you discovered that this data structure will become very long. Not only that, but it is easy to make a mistake. I noticed when I was converting it to a dictionary, I had to be careful to type the key names exactly right. The data shouldn't be cluttering up this code. It should be stored in a separate file where it can easily be modified and expanded. Most games don't have hard-coded data as we do in here. Most will load the data from one or more files at the start of program execution or through the game. So rather than defining a list or dictionary data structure with the data as literals, as we have here, we should store this data in a file and construct the data structure dynamically as we read from the file. Let's talk about files. A file is a series of bits stored on permanent media, like a hard drive or flash drive. Files have different types, and you can tell the type by the extension. The type just indicates how the contents in the file can be interpreted. We're going to be storing our data in text files. A text file is a series of bits like any other file, but those bits can be meaningfully interpreted as text. So a text encoding was used to write the file. If we open a text file in a text editor, we can read its contents. All files are a series of bits, but not all files can be interpreted as text. Try opening an image or music file with a text editor and you'll see what I mean. The text editor interprets the bits as text, but the bits weren't written out to the file as text. The bits aren't organized into characters. They need to be interpreted as an image or as music, depending on the file. Now, a text file is composed of bits that can be interpreted as characters, but we might also add some structure on top of that using those characters. Our Python programs are text files that have additional structure in the text, the structure of a Python program. A JSON file is another example of a text file that has additional structure in the text. JSON is a common way to structure data, so it's well worth learning. JSON is an acronym that stands for JavaScript Object Notation. You can pronounce the acronym JSON or JSON as I do. JavaScript is a language for scripting web browsers. Many languages, including Python, have libraries for reading and writing JSON data. Let's create our dungeon in a JSON format. I'm going to select our dungeon, which is now a list of dictionaries, and I'm going to copy that and paste it into a new file right here in idle. You can use any text editor to create a JSON. Now, I'm going to save this file as abby.json. I'm saving this in the same directory as my program. Let's look at this in the System Explorer. You can see that the icon for this file is a sort of stylized document with the JSON logo, a Mobius strip, at the bottom. It's a text file, but the JSON extension we've given it tells humans, and any language-sensitive editor reading it, that it's in JSON format. You can see that idle isn't doing anything special to format this document, but if I open it in Notepad++, for example, the punctuation, the strings, and the numbers are all colored differently. Our Abby definition is actually a proper JSON already, and it was before too, before I changed the locations from lists to dictionaries. A JSON can be composed of a string or a number, or if you want to have more than one string or number, then you can enclose those strings and numbers in either an array, which is like a Python list, delimited by square brackets, and in which the elements are comma separated, or you can enclose them in an object, which is like a Python dictionary, and is delimited by curly braces, again with elements separated by commas. Strings are enclosed in double quotes. And as we did with our Abby data structure, you can nest arrays and objects inside arrays and objects. The keys for objects in JSON must be strings. In JSON, keys are called names. So we can't dump any dictionary into a file and call it a JSON, but we can create a structure that is quite complicated as long as we stick to the data types I just listed. Our Abby, for example, is an array of objects, and each object, which is one location in our dungeon, consists of 5 name-value pairs. The names are name, description, exits, visits, and inventory. Of those, the values for name and description are strings, the value for visits is a number, and the values for exits and inventory are objects. One is string number pairs, and the other is string pairs. I'm going to open our Abby JSON in a web editing tool called JetBrains WebStorm and have it reformat the document for me so it's easier to read. I'm going to select it and choose Reformat Code from the Code menu. Many language-sensitive editors will reformat your code or structured file according to the standards for that file type. If I reopen that in idle, notice that it's formatted nicely now. I might prefer to edit it in a text editor that recognizes the JSON format, though, because it makes it easier to distinguish the components. Do also note that when you open in idle, you need to choose all files from the pull-down in the lower right of the dialog box, or idle will show you only the Python files. Once formatted, you can more easily read the contents of the data structure, and you can see how it will be easier to add and change locations in this format. You don't risk accidentally changing working code because the only thing in the document is this data structure, which is now spread out over more lines. Now, how do we get it into our program? I'm going to show you in the console first, so we can play around with it a little before we add the code into our program. The first thing I'll need to do is load the JSON module with import JSON. The JSON file reading and writing functionality isn't built into Python automatically. We need to import this module to get it. The idiom for reading a file in Python is to write with open paren, and then the name of the file, quote, abby.json, close quote, and then the mode, quote, r, close quote, close paren, as f, colon. And then on the next line, indented, I'm going to use the JSON library to read the file into a data structure. I'll write abby equals json.load. Let's go through that piece by piece. Open will open a file and return a file reference variable if successful. I have a whole video on errors that I've seen when teaching students to open files. So if you're experiencing an error, I recommend watching the video for ideas on how to solve that. I'll link it here. A file reference variable is a variable that allows us access to the contents of a file. I've called that file reference variable f, but you can call it anything at all according to Python's variable naming rules. The file name that we're passing as an argument to open is really the path to your file, including the file name. I'm keeping this to the file name by putting the file in the same directory as my program, but it could be a path through folders. If you're comfortable with file paths, put the file wherever you like and write a relative path here to the file. It's enclosed in quotes because the name of a file, or the path to a file, is a string. We're reading the file, so the mode that we're passing as the second argument to open, which is also a string, is R for read. When we write, the mode is W for write. The json.load command will read the entire contents of the file, referenced by the variable that we pass to it as an argument, and create a Python data structure from it. If the file consists of one string, then JSON.load will return one string. If the file consists of a JSON array, JSON.load will return a list. If the file consists of a JSON object, JSON.load will return a dictionary. And the same for all of the subparts of a larger data structure like an object or an array. Let's see how JSON.load did with abby.json. I'll type abby, the name of the variable we read the file into. And you can see it's a list of dictionaries. It's exactly our abby data structure. We can type abby sub0 subname, and we get the cloister. To incorporate this into our game, we will type import JSON at the top under our docstring to import the JSON library. And then at the top of main, where I'm creating the abby, I'll put my code to read the file. And because the abby.json file is in the same folder as this code, this program will work exactly as before. Now, file reading can go very wrong, and if it does, then we're left without a dungeon. What if the file gets moved, edited, or deleted? What if there's something wrong with the storage medium? We'll want our game to fail gracefully. So I'm going to move the file reading into its own function, and we'll look at how to guard against those issues. Over main, I'll write a function, def load abby, file name of type string, returning list of dictionary of string object, and then a docstring, load the abby dungeon from the file name, or return a default dungeon. I'll cut that code from main and put it under the function header and return abby. And in main, I'll set abby equal to load abby, and I'll pass in the file name. In the load abby function, I'll change the hard-coded file name in the call to open to the file name variable passed in as a parameter. So now this probably seems like a whole lot of bother for nothing, but now we'll add in all the error checking. First, let me run the program and confirm this still works. Now, let me break it by passing in the wrong file. I'll just change it to abby2.json. That file doesn't exist. We'll get the same error as if somebody had moved or deleted or renamed abby.json in the desktop. And let's run it. We get a spectacular crash that says file not found error. I'll put it back. And let's try another error. I'll go into abby.json and I'll just put in an extra open curly brace at the top. So now it's not syntactically correct. And when I run the program, again, another spectacular crash with JSON decode error. I'll remove that curly brace. These crashes with red errors are called exceptions. Python throws an exception when an exceptional condition occurs while the program is running. We can catch those exceptions in our program and handle them in a way that allows our program to continue running, or at least fail gracefully. To do that, you have to put a try except block around the code that can throw the exception. And in both cases, that was our block of code that attempted to read the file. So I'll write try : before the with statement, and I'll indent the with statement. This means try this code, and if it runs, great. And if it throws an exception, let me handle it. And we handle it in one or more except blocks. We can write, at the same level of indentation as try, except exception as E, and then print an error message. I'll print an F string, asterisk, 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 an unexpected error occurred, : curly braces E, asterisk, 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 and that will let me, the programmer, know that something went wrong and dig into it by reading the information in E, the exception that got thrown. So that will be helpful for me, but not so helpful for the player. I need to return something for Abby, so this can fail gracefully. I'm going to create a dummy Abby here, a list of one dictionary, and the name of the location will be dark room, with a description, you are in a dark room with no exits, best go home, and then exits and inventory are empty dictionaries and 0 visits. This could be as interesting as you like. In the future, we could put something here for the player to pick up and examine, whatever we like, but I'm going to include this in the exception code. This code will execute if there's an error, and so this is the Abby that gets returned if there's an error. And let me create my 2 errors again and run that once for each error. First, the wrong file name, and you can see an unexpected error occurred, error number 2, no such file or directory, abby2.json, and then you are in a dark room with no exits, best go home. I can still play. I can look at my inventory, which is empty, and try to go directions, but I'm not going to get very far. Best quit. And now I'll fix the file name and put that rogue curly brace at the top of the JSON and run it. And I get different information from the exception E. An unexpected error occurred, expecting property name enclosed in double quotes. But I'm still in the dark room without much to do. You know, I'm just going to leave that error in the JSON for now because we can actually handle specific exceptions differently. Let's take a look. Between try and except, I'm going to put 2 more except blocks, one for each error we've seen. And I'll print specific messages for each. Except file not found error, print file not found, file name, and except JSON.json decode error, print invalid JSON format in the file name. The way this works is Python will look at each except block, starting at the top one, and move down until it finds one that matches the exception that got thrown. So you should list more specific exceptions first, and then go down to the general exception, the parent of the other exceptions. Because I always want to be returning something, rather than creating my dummy Abby in all of these exceptions, I'll create that up at the top of this function. Then if we can actually read in the Abby, it will get replaced with the real Abby. But if we can't, and we end up in one of these exceptions, the dummy Abby will be returned. Of course, if you wanted, you could make a different specific dummy Abby for each exception. Let's run it again. Remember, I have an error in the JSON file, and I get invalid JSON format in file abby.json, and I'm in the dark room. Let's run it with the bad file name. I'll fix the JSON. I get file not found abby2.json, and I'm in the dark room. Okay, so we are doing really well. We can read our Abby from a file, which means we can add rooms using this pretty easy to modify data structure in the file without having to mess with our code. And if we make a mistake or accidentally delete or lose the file, our program will fail gracefully. But we also want to be able to save our progress, right? So how do we write a JSON? Let's add save and restore commands to our game. At the top, in my constants area, I'll define save commands as v and save, since s is already being used for south. And I'll define restore commands as r and restore. And down in main, where we're processing commands, I'll add 2 more elifs, one for saving and one for restoring. Within main, I'm going to define 2 constants for our files. Start dungeon, a string, will be abby.json, and then save dungeon will be save.json. I'll replace the hard-coded file name with start dungeon. If the user chooses to restore, we can load our Abby from save.json. So I'll simply copy and paste that line of code, but instead of restoring from start dungeon, we'll restore from save dungeon. Let's imagine we have a function called save Abby, and if the user chooses to save, we'll invoke save Abby and pass in our Abby and save dungeon. Let's have that return a Boolean, letting us know if it was successful. So if save Abby, Abby save dungeon, and we'll print a message like saved, and then else there was a problem saving. Now let's write that function. Because our Abby data structure is already in a structure that translates directly to a JSON, this will be easy. I'm just going to copy load Abby and paste it, and rename it to save Abby, set the return type to Boolean, and change the parameter list. Then rewrite the docstring to save the Abby dungeon to the file name and return true if successful, false otherwise. Now, in the function, we'll annotate a variable success of type Boolean and give it a default value of true. We will assume this file writing will succeed. Within the try, we'll write with open file name w as f. This time we're writing a file, not reading it, so we're going to pass w as the mode. This mode will create a file named filename, so if there already was a file with that name, it will be erased. And we don't have to worry about a file not found error, because we're creating the file. Indented under the with, we'll invoke json.dump and pass in Abby, the value we want to write to the file, and then the file f. And finally, I'm going to add indent equals 4, which will make the file easier for a human to read. Now, we'll keep that final exception, but different things can go wrong with reading versus writing a file. Again, we don't have to worry about the file not being found, but we might not have permission to write to the directory, so we'll write an exception for permission error and print permission denied cannot write to file name and set success to false. There could be a problem with our data structure that prevents it from being turned into a JSON. For example, if we slipped a data type in there that can't be written. So we'll have accept type error as E to catch that one. And we'll display the specific message so we can track down what's been added to the data structure, unable to serialize data to JSON, E, and set success to false. Finally, something could go wrong with the device we're writing to, so we'll also catch an OS error as E, and print file system error while saving file name E, and set success to false. We'll also add that to the general exception catch, and then we'll return success. Let's play the game, move the inventory around, and then quit. Play again and load our game in. I'll put the book in the library and the knife and skull in the garden, and then I'll save with V. Now let me run it again, go north and confirm the book is in the church, and then I'll type R for restore. It says church, but there's no book. Let's see if it's in the library. It is, and if we go west twice more, we're in the garden, where there's a skull and a knife. Now, we've saved our dungeon, but there are a couple of things we're not saving that are part of our game state. One is the player's inventory. If we don't save that, then we can disappear items by picking them up and saving, and then restarting the game and restoring. And the player's location. When we restored, we weren't moved to the location we were in when we saved. How do we add these to our save file? There are a few different ways we could handle this. One is to separate save and restore from loading the original dungeon, and only save and restore what might change. So we'd create a new data structure for saving, write it out, and then when we restore, we'd read it in and put what we read in into the appropriate variables. Another approach is we could have a separate save file for the inventory and the location, and read and write both files on save and restore. Another approach is we could add player inventory and location to the data we load in initially, and also to the data we save and restore. The simplest solution is the last one, just adding some more data to what we save out, so I'm going to do that. That is not how I save and restore in the finished game I showed you back in the first video, but that game was very different because it was an object-oriented version of this game. That's the subject of our next video. Let's edit our Abby JSON. Right now, it's a list of location dictionaries, or an array of locations objects in JSON terminology. What if I put a dictionary, or object, around this, so curly brace at the top and at the end, and inside this I'll write current location 0, player inventory, open close curly brace, and dungeon in front of our original list. In load Abby, let's make an equivalent default Abby by putting curly braces around what we have and adding the same key value pairs and a key of dungeon for the list containing the darkroom location. Now this returns a dictionary of 3 string object pairs: the current location, the player inventory, and the Abby location data structure. The only other things we need to change are down in main. First, unpacking this and pulling the values for our Abby, the current location, and player inventory out of it. I'll store the initial data structure in a variable called data of type dict string object, data equals load Abby start dungeon, and then Abby, a list of dict string object equals data dungeon, current location int equals data current location, and player inventory dict string equals data player inventory. Down in the restore command, we'll do the same thing, minus the annotations, and making sure we load from save dungeon and not start dungeon. When we save, instead of passing in our Abby, we will construct data equals dungeon Abby, current location, player inventory, and then pass that into save Abby with save dungeon. So we pack our 3 variables into a dictionary. Let's run that, move some items around, put one in the inventory, and move to a non-cloister location, save and quit. Then run again and restore. And you can see we're in the location we were in when we saved. We have our inventory, and items are where we dropped them in the dungeon. JSONs. They're really not that bad once you're used to dictionaries and lists. For some practice, well, you could make up any data structure and save it to a file and read it in. How about the monster dictionary I've been encouraging you to create for the last few videos? If you created the monster player game, then you could save out the monsters together with your player's stats and then read them back in. Maybe your player stats include the monsters that the player has defeated. When you're feeling confident with reading and writing JSON files, join me for the next installment of Adventures with Python. As always, have fun and keep coding.